All right, so now what we're going to do is start looking at some exam questions and how we, I guess, what we're expected for. Now, it says determine the shortest distance between the house and the pump. We've got to get from here and then get to here. Well, it's quite clear that the best way to do that is to go from here to here and there to there. It's not asking to cover every edge or vertice. That's pretty straightforward. 160 metres. Shh. How many vertices on the network have an odd degree? Well, there's 2 because this one is 5, has a degree 5, and this one has a degree 5. Now, of course, you would have labelled the other ones as well. So, how many vertices? 2. A lot of your further mass marks are 1 markers. They're either right or they're wrong. That's why it's really important when it comes to the explanation ones that you know exactly how to answer them. Now it says here the total length of all the edges is 1180 metres. Bit of a trick question here. 1180 metres. A journey starts and finishes at the house and travels along every edge in the network. Could a Euler circuit exist for this network? How could a circuit exist? Because doesn't a Euler circuit doesn't have to be all even vertices? No, 2 odds is a Euler path. Sorry. So all even vertices is it for a Euler circuit, for a Euler path. Now we have exactly 2 odd, and the only way we can get the 2 odd, or the only way the only way the path can exist is if we start and finish at an odd vertice. So let's think about it. We've been told something. We've been told that every edge, when we add them up together, is 1180. So we can do that, which is called a Euler path. But the problem is, it says here we have to start and finish at the house. So, where are we going to start? Well, I guess what we're going to do, it doesn't really matter what it is, but if I start here, I can let's just say that I go here, then go to there, then go to there, there. Okay, I've just done what we call a Euler. Have I done a Euler? No, because have I gone through every edge? No, and we don't have to go through every edge at the moment. We don't even have to worry about that because we've been told that the total length of all the lengths of the network is 1180. But what's one thing we know about a Euler path? If I start here and I go through all the edges, I'm going to finish there, aren't I? So how do I get back to the house? I've got to travel how far? No. How do I get back? If I've started there and I've finished there, don't I have to go 70 more? Yeah. So therefore, the shortest distance travelled is 1180 plus 70, which is equal to 1250 metres, and that question was not done very well at all. Because that's students who didn't exactly understand, or because they didn't ask you to do a Euler circuit or Euler path or anything, but by noticing that we had 2 odd vertices and you have a network which goes through every edge, starts and finishes at the house, it actually has to go here and then go back to the house again. So that's 1250. Now, this is an example of my minimal spanning trees. On the diagram, draw the minimum length of pipe needed to supply water. Now, we talked about Prim's algorithm. What do we do with Prim's algorithm? We start with the edge with the lowest weighting. Now, isn't there quite a few of those? 240s. Yeah, there's 340s. Now, remember that there's going to be multiple answers for this because I'm going to start there. Now, I then go make the decision. Do I go to the 7? This vertice has to be covered. So we've got a pipe which needs to go there. We're going to go the 70 option, aren't we? Okay, so far so good. What about this one? Do we go, would it be advisable to go 40?
Yeah.
Okay, we're going to go 40. Now we're going to sort of stop there, and then we're going to sort of say, what about, we're going to go 50? Okay with that? All right, now what about 60? Down here. Let's go 60. Then go back up to 80. Okay, we've got two more vertices. 50 and then 40. Beautiful. Now, that was worth, how many marks was that worth?
3.
I don't think that would be worth 3 marks. So, that's our minimal spanning tree. How many edges do we have? Well, we have one less edge than vertices. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should have 8 edges. 1, 2, 3, 4, 5, 6, 7, 8. What is the mathematical term that is used to describe this minimal length of pipe? No. A minimal spanning tree. That'll get you a mark. Don't go, we use Prim's algorithm to do it, but it says what mathematical term is used to describe the length. It's a minimal spanning tree. All right, now let's have a look at this one. Adam, yada, yada, yada. The network shows the road connections. In kilometres, what is the shortest distance between Farnham and Carry? Now, is it asked for Farnham and Carry? So we've got to get from here, and go to there. So we can go 60 and 140 is 200. We can go 70, 110, 130. It's going to be 200, isn't it? 200 what? 200 what? Kilometres. So we're going to go this way, and then we're going to go this way. How many different ways are there to travel from Farnham to Carry without passing through any town more than once? So, what are we talking about? Farnham to Carry. Now this is where lazy students, they go, what's the first thing we're going to do? Let's have a look at the vertices. Yeah? So we're going to say that's of degree 2. That's of degree 1, 2, 3, 4. That's of degree 2. That's of degree 3. That's of degree 2. And that's of degree 3. Okay, now it says here, without passing through any town more than once. Is it Hamiltonian or is it Euler's? Every town more than once. I don't know about that. Isn't it? Don't we just have to? Isn't it just Hamilton? Because Hamilton's for vertices. We just have to go through. We don't have to go through every edge. So this is a little bit of trial and error. How many ways are there to go from Farnham to Carry, passing through any town without passing through any town more than once? I'm not sure if there is. I'm going to pause this and I'm going to get you to have a bit of a go at it, please, because this Hamiltonian is a bit of just trial and error. Shh. So, just quickly, it says how many different ways are there to travel from Farnham to Carry without passing through any towns more than once, but that doesn't mean that we have to go through every town. So, I'm going to say that there's, I'm going to tell you that there's 6, but I'm going to tell you that we can go FDC, that's one of them. We could go FEDC. We could go FEBC. We could go FEABC. You don't have to actually list them, by the way. I'm just sort of showing you because it's just the answer worth 1 mark. What else can we do? FDEBC. And what was it? FD. F, D, E, A, B, C. Yeah? There's our 6. So these are the sort of questions, and that wouldn't have been done as so well by many students, more because they're not reading the question. An engineer plans to inspect all the roads on this network. All the roads. In other words, we're thinking Euler, because it's every edge. He will start at Dunlop and inspect each road only once. Start at Dunlop. Look at that. Has an odd degree. At which town will he finish? Well, which is the other one with an odd degree? Breeden. Pretty straightforward, isn't it? If you know. So he starts at Dunlop, finishes at Breeden. Another engineer decides to start and finish her road inspection at Dunlop. If an assistant inspects 2 roads, this engineer can inspect the remaining 6 roads and visit each of the other 5 towns only once. How many kilometres of road will the assistant need to inspect? Another engineer decides to start and finish her road inspection at Dunlop. Start and finish at Dunlop. Now they've got to go through every road. Can they cross? So we have to read it. If any assistant inspects 2 of the roads, this engineer can inspect the remaining 6 roads and visit each of the other 5 towns only once. How many kilometres of road will the assistant need to inspect? I'm going to pause it there, and I'd like you to have a